next talk, we're going to switch from medicine to automobiles. So here from Ford.
Hi everybody, I'm David Simcha-Levid. I'm not from Ford, I'm from MIT. This project is part of the MIT Ford Alliance. From MIT, we had three PhD students involved. One ended up as a faculty at Duke. One who finished last year ended up as a faculty at Cornell. And the third is a current PhD student at MIT. And from Ford, we have two people representing this project, but there were, as you will hear later on, people across the company involved in this initiative. What I'm going to do, I'm going to start with an introduction, then talk about a new way to measure risk in the supply chain, what we call the risk exposure index, go through the model, the mathematics, talk just a little bit about the implementation, and then let Ford people present what exactly was done and what was the impact on their operations, supply chain, and procurement. And then later on, if we have time, I'll talk about impact beyond Ford, how other companies, including the United Nations, have used this concept. Let me start with a few observations. In the last few years, we have seen a significant increase in the level of risk faced by many companies. And I would argue that this increase in risk is a lot because of successful implementation of strategies like lean, like outsourcing, and like offshoring. What does lean mean? Lean implies typically low level of inventory. Low level of inventory suggests that if there is a disruption, the supply chain will not be able to match supply with demand. Outsourcing and offshoring implies that the supply chain is geographically more diverse, as a result exposed to all sorts of potential problems. And this was demonstrated in a powerful way with events in 2011, including the tsunami in Japan and the flood in Thailand, affecting companies from the automotive industry to the high-tech industry. If you look, in fact, at the impact of natural disasters during 2011 on businesses, the impact was about $300 billion, mostly associated with the tsunami in Japan, but also a lot with the flood in Thailand. And if, in fact, you take a historical point of view and you look at the impact of natural disasters over the last 30 years, you can see a clear trend. Significant increase in the impact of natural disasters on businesses. As I mentioned, 2000 and 2011, the impact was slightly greater than $300 billion. A small portion, about $80 billion, this is the blue part of each bar, was covered by insurance. If you look at 2005, the impact was greater than $250 billion. Less than half was covered by insurance. Even if insurance covers everything, clearly insurance is not a solution to supply chain disruption because it doesn't cover for lost customers who will never come back. It doesn't cover for the impact on the brand, and it doesn't cover for the impact on stock performance. You ask yourself, what is David talking about? What is the relationship between disruption and stock performance? Here is an example. This is a company you know very well, Mattel, the world's largest toy manufacturer. In August of 2007, the company recalled 18 million toys made in China because of lead paint. So what I did, I invested $1 in the stock of Mattel, and I started my investment 5 years before the disruption. And I invested another $1 in the stock of its main competitor, Hasbro, and I started the investment at exactly the same time. And I look how my investment changed over time before and after the event. And you can see before the event, the stock of the two companies moved up and down in parallel. It's hard to argue that one does significantly better than the other. But the disruption made a huge impact. After the disruption, the stock of Mattel went significantly down, and it stayed down for 2 years after the event, while Hasbro was able to distinguish itself and its stock took off and made a big difference. This is why risk management and mitigating risk is not only the focus of supply chain executive, it's the focus of the CFO, it's the focus of chief procurement officer, it's a lot the focus of the CEO and the board running the company. Now, when you think about risk, you realize, well, there are many sources of risk. I am listing here just a few examples, but you can see that I arrange this example in a very careful way. At the top, I have what I call the unknown. These are sources of risk from which we have very little data. As a result, it's difficult to build models, therefore very difficult to control. Examples include natural disasters, geopolitical problems, epidemic, and the like. At the bottom, I have what we call the non-unknown. These are sources of risk from which we have a lot of data, therefore we can build models. As a result, we can control them well. Examples include supplier performance, forecast accuracy, execution problems, and the like. Controllable or uncontrollable, companies need effective way to manage risk in their supply chain. My experience is that most companies either pay very little attention to risk, or if they focus on risk, it's typically focusing on the controllable part, right? Because they have data, they can build models. As a result, they can manage and mitigate risk. And what they tell you, look, there is very little that we can do when it comes to the unknown. For example, they would say an event like the tsunami in Japan happens maybe once every 200 years. Very difficult to predict. An event like the volcano eruption in 2010 maybe happened every 100 years. Very, very difficult to predict. But here's the problem. Each one of these events happened very infrequently, but there are so many of this type of event is that I don't know what will hit the supply chain in the next 12 months. What I do know, something is going to go wrong. And the question is either a way for companies to build strategies that allows them to respond effectively to different types of events. And so to summarize the challenge, very difficult to predict the unknown. The impact of disruption can be devastating. We saw a few examples. Some companies will say, look, we understand this. What we are going to do, or what we do, is we go and visit each one of the suppliers, right? And we try to make sure that each one of our suppliers have effective mitigation strategies. The problem with that is that if you are IBM or if you are Ford and you have thousands and thousands of suppliers, by the time you finish this exercise, the supply chain has changed completely. So we need something more scientific, something more systematic that allow you to identify, based on the data, where are the bottlenecks and where are the risks. Add to this is that if a company is focusing on risk mitigation strategies, a lot of time what you will see, it's all based on intuition and gut feeling. What does it mean? Two executives will sit in a room and talk about a supplier. I will say, this supplier is very risky. My colleague will say, it's not that risky, we'll take the average. Right? It's not clear what it means. The other thing that they will say, look, we understand, that's very difficult. Let's equate risk with high total spend suppliers. That is to say, the suppliers where we spend a lot are probably the risky suppliers. What I'm going to highlight here is that when you do systematic analysis, you will find from the mathematics that risk is hidden in unexpected places. And the idea is to build models that allow to identify hidden risk and therefore also identify mitigation strategies that companies can use. And so here is the challenge at Ford. Very complex supply chain. In the initial implementation, we focused on the assembly facilities in North America, but the supply chain for these assembly facilities is global. It includes suppliers in Asia, suppliers in North America, suppliers in Europe, suppliers in Latin America. So it's a very complex supply chain. A little bit more, 50 manufacturing facilities that Ford has, 10 tiers of supplier, 4,400 just tier one locations, supplier side, 55,000 different parts. So you are talking about a complex supply chain. There is no way with intuition and gut feeling you can really identify where risk is hidden. So let me describe the concept, the model that we have developed using a simple example, and then take you through the implementation. The model, the framework, the concept that we develop is completely new. It's what I call the risk exposure index. I will present it on this example. Here is a simple supply chain. You look at the supply chain, you ask yourself, where are we exposed to risk? Should we focus all our resources in reducing risk at the engine plant facility, or maybe at the raw chemical suppliers, right? So I'm going to introduce a couple of concepts and then show you how this concept leads to new mathematics that help us identify hidden risk in the supply chain. The first concept is what we call time to recovery. What is time to recovery? Time to recovery is defined as the time it takes to recover to full functionality after a disruption. You talk to the raw chemical suppliers, and the raw chemical supplier says, my time to recovery is 2 weeks. Why? Because I have right now a facility in Germany. If this facility is disrupted, I have another facility in Asia. I can switch production to the facility in Asia, and it takes me about 2 weeks to ramp up production and arrive at the capacities that I have today. And so we know time to recovery is 2 weeks, and in the same way, I can collect data on other facilities. Of course, you immediately have in mind the following question. If I call a supplier and I ask, what is your time to recovery? Supplier is going to be optimistic. He's not going to say 6 months. He's not going to say 5 weeks. He's going to be optimistic, thinking about being able to respond quickly. So how can I identify? That's a later question we are going to ask. How can I identify bottleneck suppliers where it's very important to understand what's their time to recovery and distinguish those from other suppliers where even if they make plus minus 20% mistake in the time to recovery, it really will have no impact on risk exposure to the company. But right now we will start collecting data on time to recovery and trying to see how I can use it. So once I have information about time to recovery, I can determine performance impact. Performance impact can be any KPI that the company is interested. For example, impact on lost production. For example, impact on revenue. For example, impact of profit. So take for example, the raw chemical suppliers. We remove these supplier for a period of 2 weeks, and we ask, what is the impact on bottom line when this supplier is out of the supply chain for 2 weeks? For example, what is the impact on lost revenue? Of course, when I remove a supplier from the supply chain, it's not that I have to stop matching supply with demand because the pipeline is full with inventory. So I want to take the entire supply chain without these suppliers, this supplier for 2 weeks, and determine the impact on bottom line. In this case, the impact was loss of about $400 million in revenue. And I can do this supplier by supplier. And all of a sudden, we realize that I have a way to prioritize risk in different facilities, right? The engine plant in this simple example is risky, but it's not as risky as these chemical suppliers, right? If I need to decide where to allocate resources, I now have an ability to decide where is risk hidden, and that I probably should focus on the contract manufacturer, or I should probably focus on the assembly facilities. This is where risk is high, and this is what we call the risk exposure index, which is really a way to normalize this impact on bottom line and to rank suppliers by their specific risk. And so once we had the framework, I want to highlight what the framework takes into account. Framework takes into account all the portfolio of products that the company has. It takes into account bill of material. It takes into account margins and production volume. It takes into account pipeline inventory. As I said, when a facility is down, it's not that I immediately stop serving customers. I can still use what is available in the supply chain, together with taking into account, for example, alternative resources. It takes into account the time duration of a disruption, and most importantly, every time we analyze the financial performance or performance impact, we simulate the best response that the company may have to that disruption. by simulating the best disrupt for a specific disruption is we solve an optimization problem that tell us what is the best thing that the company can do with the remaining resources and the given demand forecast for customer demand. And so the mathematical model is described next. In this mathematical model, I will refer to plant and part combination. So a node in my model is a combination of a specific plant and a specific part. A link connecting two nodes is a transition link where there is a flow between different facilities in the supply chain. And all of a sudden, you can imagine this complex network transfer into an optimization problem where what I'm trying to do in this risk exposure index is to minimize total loss. And as we said, loss can be defined as revenue, profit, loss production, subject to multiple types of constraint. The first constraint is bill of material constraint. We say it's easy to see that we are focusing here on total production at node J. It's limited by what's coming to that node from upstream facilities. The second is part allocation constraint. What it says is that the total amount that I can push to downstream facilities from a specific node, it's limited by what I can produce at that node plus the inventory of that component at that specific node. The next constraint is a disruption. And you notice that I can remove one node or I can remove a cluster of nodes because maybe there are facilities that are all in the same territory, in the same region. I'm worried about earthquake that will wipe up many of the suppliers that are all in a close proximity. The next one is a demand loss constraint. It basically says that the loss is greater than the demand minus the supply. And finally, plant or production capacity constraint. It can be at the plant level or at the production line level. And so when we apply this to Ford supply chain, all of a sudden, if you remember, we said 4,500 tier one supplier site. Well, the model says, look, out of these 4,500, about half, right, pose zero risk on the company. Later on, I want to contrast this with what they used to apply before, right? In addition, there are another 800 where they pose very little risk, but around 10% of the suppliers pose huge risk on Ford. You ask yourself, who are these suppliers? Are these suppliers the high total spend suppliers or maybe different suppliers? So let's look at that question. What I have here on the Y coordinate is total spend at a supplier site, right? We are not showing the specific number, but this is data straight from the system that we'll show you. And on the X coordinate, I have performance impact, and here I'm looking at loss. So you look at this supplier at this point, you say, yeah, I understand. This is a supplier where total spend is high. Certainly it's risky. But where is the high risk? The high risk is concentrated with supplier where total spend is very small. I like in particular this supplier, right? Who paid attention to this supplier, right? Supplier is, total spend is almost zero. But if this one is down, enormous risk on the company, right? This also tells you that here is an opportunity to focus on supplier segmentation, right? We always talk about supply chain segmentation. This is different. This says, if I'm a procurement officer, I want to segment my suppliers because the strategies that I need to apply depends on where the suppliers are on this framework. If I have suppliers here, these are relatively low risk suppliers. It's low touch. I can just monitor inventory and trigger an action when inventory goes down to below a certain level because it means that risk has increased above a certain tolerance. This is a problem, right? These are suppliers where risk is high, but here Ford has an opportunity. You go to this supplier or this supplier, and Ford is in great position to push the supplier to have another facility because total spend is very high. But when you are here, at the bottom right-hand side, you have a problem. Because you may say it's all about inventory, but lean is the philosophy, inventory is not the solution. You may say, well, let's go and push this supplier to have another facility. But Ford is not in a great position necessarily to push them to another facility because total spend is very low. Here, you need to be extremely careful, right? You may sometimes, as some of the implementations that we have done in the last 2 years show, you need to design the product differently. You need to standardize component. Why? Because when you standardize component, you give this supplier more flow, your total spend is higher, you basically are in a great position to push the supplier to have multiple facilities. Now I want to go back to the idea of time to recovery. I go to a supplier and I ask about time to recovery, and the supplier will give me a number, and I'm starting to get worried, right? This time to recovery may be optimistic. So how can I identify those suppliers where I have to be very careful with their information and distinguish them from all the other suppliers where plus minus 20 or 30% is not a huge problem? And so the concept that I showed you is time to recovery. Let me remind you what it is. It's time for a node in the supply chain to return to full functionality after a disruption. I want to show you a dual concept of the same idea. The dual concept is time to survive. What is time to survive? You remove a node from the supply chain and you ask, without this node, how long can I match supply with demand, right? It's not zero because some inventory exists. Maybe there are alternative suppliers. But I can find it. I don't need the supplier to tell me anything in order to find what is the time to survive for that node. And so as long as time to survive is greater than time to recovery for every node, I have a resilient supply chain. All of a sudden, you hear a lot about resiliency and robustness. We have a very precise way to define what is a resilient supply chain. A resilient supply chain is a supply chain where this happens, because for every node, by the time you recovered, you can keep on matching supply with demand, because time to survive is greater than time to recovery. But this also gives you an opportunity. If you look at a supplier and time to survive is 60 weeks, you say, well, that's not maybe the bottleneck. The bottleneck is with some of the suppliers where time to survive is 1 day or 2 days. And you look at so this is the formulation. The formulation is really a dual. Remember in the original one, I minimize losses. Here I'm maximizing time under the same set of constraints. It's really applying a dual to the same set of problems that I showed you. And the application to Ford is presented here. Time to survive, right? And the number of suppliers with the same time to survive. So you look at the right-hand side and you say, well, these are suppliers where time to survive is long, 40 weeks, 50 weeks. I'm not worried about them. I'm worried about these suppliers. Time to survive for this supplier, 1 day, 2 days. These are the suppliers where I have to understand their time to recovery very well. And that's what was done in this project and other project where we apply exactly the same concept. This also gives you a second opportunity. You look at the right-hand side and say, look at this. There are many suppliers whose time to survive is more than 50 weeks. Well, how did you achieve the more than 50 weeks? You build a lot of inventory because you're thinking this is a big problem. Here is an opportunity to say, how much strategic inventory I need? Maybe I can reduce it to 20 weeks and cut my inventory almost by half, right? So it's not only about risk mitigation strategy, it's also cutting a cost associated with what you already implemented in your supply chain. And so I will just describe the idea in the Ford implementation, and then Oleg here will take over and talk about what happened at Ford. So the idea is that once we developed the mathematics and it was tested, and as I said, 3 PhD students have been involved in the project, we realized this will work only if it's part of the day-to-day procurement process that directors at Ford use to identify risk in their segment and to change their strategy depending on risk. So we developed a decision support system that is used on a daily basis. It's used for 3 objectives. It's used for strategic, tactical, and operational. Let me start with the strategic. The strategic is to identify exposure to risk, to identify risk mitigation strategies, to segment suppliers, and in particular, to cut cost associated with mitigation strategies they have built before and are very costly, right? This is the right-hand side of the graph that I showed you. The second level is a tactical level. The system allows a procurement manager to keep track of risk exposure every morning and to identify, well, inventory for a specific component went down below a certain level, risk has increased an acceptable level, we need to make a change or we need to understand what happened. And the last one, and I love the last one, is because it's used for operational. If you remember 6 months ago, there were tension in South Korea because of development in North Korea. Procurement at Ford were very concerned about the increase in risk and exposure to the company. System allows them to zoom at their suppliers in South Korea, identify exposure to risk for Ford associated with this supplier, and design mitigation strategy. That's no longer the strategic. That's no longer the tactical. That's how do I respond to a problem that happens this morning? And so I'll ask Oleg to join me and talk about the system.
Thank you, David. My name is Oleg Gusikin, and I'm happy to represent Ford team who work on this project. And as David mentioned, we have developed and implemented a decision support system, the high-level architecture represented on this slide. The risk exposure model implemented using Java and Cplex library. Input to the model is based on integration of multiple data sources, multiple corporate data sources, which includes vehicle volume planning and forecasting system, MRP system with all the inventory and all the links between the customers and suppliers, purchasing information, as well as vehicle profit margins. So first, let's talk about integration of these data. So integration and of these multiple corporate data sources, as well as mapping this data into the network model for optimization and further risk analysis is not a trivial task. And it's further complicated by the amount of data we have to process. So we develop a graph, ETL, extract, transform, and load procedure, which allows us for efficient and effective mapping of all the corporate data into the network model and for further efficient analysis. The user interface implemented using Tableau system. And here I have some of the example. This represents the supply base for North American assembly plants. The size of the circle and the color of the circle represents the impact of the given supplier onto these assembly operations. So this supply base represents not only suppliers who directly ship to the assembly plants, but also lower tier suppliers together with the effect on assembly operations. So at the bottom, we have also a list of those suppliers with all the parts, total financial impact, as well as volume impact. Well, for confidentiality reason, we had to disguise all the specific data related to the suppliers and the parts. This system is interactive, and it allows to go from the assembly plants to the supply base, or from the supply base to effect on the assembly operations. For example, our risk analyst can zoom on a specific supplier or specific region and see what kind of suppliers and what kind of effect of the suppliers in this specific region will be on our supply base. So finally, I just want to summarize the benefits to Ford. Well, first of all, as David also mentioned, we provided an internal proactive, and proactive being a keyword, tool for risk management. On a strategic level, first of all, we generated a critical supplier list and part list. And again, as David mentioned, our risk group originally had a list of 1,500 suppliers, which were based on a highest total annual part cost. Our system generated a list of 2,600 suppliers. From this list, 1,100 suppliers were the same as in original list in supply chain management. But with this new list, we found that 1,100 suppliers represented a hidden risk which we never monitored. And at the same time, we found that 400 supplier sites really don't represent any significant risk to our operations. Some more specific examples of those suppliers, and this is what the first example, that's what David mentioned as his favorite supplier. Apparently, it was very interesting. It was one of the sensors to the vehicle. I cannot tell which one. But it was like very low cost sensor, which had a very low total annual part spend, so it never was monitored before. But we found that there are only 2 sites which produce this sensor, and it goes to all our vehicles. So if something happened to this supplier, we have a really significant effect to our operations. So this discovery triggered the further investigation by our commodity team, who designed optimal mitigation strategy in case something happened to those suppliers. From this list, also we found the significant number of fasteners commodities. And again, this is a trigger further investigation by our commodity teams. Well, some of those fasteners are really industry standards, and we can go and buy it in Home Depot. However, it was a subset of those fasteners which were very unique to our operations. And in case of disruption, they will provide a significant impact on our operation. And again, in this case, commodity teams develop a mitigation strategy for those type of suppliers. And last but not least, as David mentioned, we use it on operational level right now. So, well, as you know, a lot of things happening around the world, basically on a daily basis, and our risk management team looking on the specific regions to see what kind of supplies we have there and what kind of effect it will have on our operation, and prioritize resources to deal with these potential anticipated issues. And again, concerns can include natural disasters, labor strike, or political unrest. Finally, I would like to give credit to some of our colleagues at Ford, Steve Farasi from Ford Purchasing, our colleagues from IT, Don Noyles and Don Ryan, Ford Research, John Ginder, and we would like to thank MIT Alliance, who sponsored this project.
And before we finish, I want to just add that this is what you heard here really has nothing to do with Ford. Really has nothing to do with automotive. What we have developed is a powerful way for companies to identify and mitigate risk in the supply chain. I want to give 3 examples. The first, in mobile phone, one of the largest mobile phone companies in this country is using this on a day-to-day basis to manage risk in their supply chain. The second, it's used in pharma. And the third, which is my favorite example, is the UN just published a report where they use this framework, this concept, without us not knowing anything about what they are doing. They published a report. They said we use the risk exposure index to identify risk in emerging countries. And they talk specifically about Thailand, and the trigger for Thailand was the events in 2011, and they talk about other countries. But this is the power of developing a concept, a model, a framework that allows you to look at risk across companies, across facilities, across supply chain. Stop you.
I thought Ford is your favorite.
Ford.